All right, we're asked to classify this triangle by both its sides and its angles. So just really quickly, think about what names we give a triangle when we know its side lengths. When all the sides are the same, we call it equilateral. When two sides are the same, it's isosceles. And when no three sides are the same, we call it scalene. We have 4 different ways that we classify a triangle by its angle measures. When a triangle has all congruent angles, we call it equiangular. When a triangle has a right angle in it, we call it a right triangle. If it has one obtuse angle in it, we call it obtuse. But then we call it acute if all 3 of the angles are acute. So we have to figure out 2 different names for this, a sides name and an angles name. Our first step here would be just to plot these points so we can get an idea of what this looks like. Now notice that this graph is going by 2s, so to plot the point 1, 1, it's going to be inside of this first square grid on the grid. And then B is going to go over 4 and it won't go up at all, so it'll be right here on the axis. And then C is over 8 and up 5. So again, it's not going to be a lattice point, it's going to be over 8 on one of the vertical lines, but it's going to be in between 2 of the horizontal ones. All right, so if I would connect these and make my triangle, I can look at this and think to myself, well, that looks like it's an obtuse triangle. Could also say, well, that looks like it's a scalene triangle. But I want to make sure that that is the case. I want to make sure AC and BC look like they could be congruent. And angle B seems obtuse, but it could be a right angle. So I need to verify. The first thing that I want to do is I'm going to verify what kind of triangle this is. And we can do this in several different ways. We can use the distance formula, we can use slopes, we can determine whether or not this is a right angle here at B. But because I also need to know if it's obtuse, I think the best thing to do is probably use the Pythagorean theorem. So I'm going to find the distance. I want to know the distance between A and B. And to know the distance between A and B, I use the distance formula, which is really just the Pythagorean theorem. So I notice from A to B, I go down 1, and I go over 3. So if I have a distance of, those are the 2 legs of my right triangle, so I would have 1 squared plus 2 squared, and then I know that I have to square root that in order to find the actual value. So I know that the distance for AB is going to be the square root of 5. All right, I'm going to apply that same process for BC. And so if I make my right triangle off of B and C, from B, this leg right here goes over 4, and this one right here goes up 5. So it's going to be 4 squared plus 5 squared, which is going to be 16 plus 25. And we know that that equals 41. All right, our last side that we haven't done yet is AC. So we're going to do AC, and again, I'm going to draw my right triangle. Now this one went up a total of, it looks like 4, and it went over a total of 7. So I'm going to have 4 squared plus 7 squared, which is equal to 65. All right, so from these 3 lengths that I just found, it's very obvious that the length of AC is the longest. So if this were a right triangle, we would consider that one to be the hypotenuse. Also, it's very obvious that all 3 side lengths are different. So it's safe for me to go ahead and classify this triangle by its side lengths as scalene. So this is indeed a scalene triangle. But now we have to determine whether or not it is a right triangle, acute triangle, or obtuse. I'm suspicious that it's obtuse, but I want to verify. So I'm going to take the square root of 5 for one of the legs. I'm going to take the square root of 41 for one of the legs. I'm going to square those and add them together. And we know for this to be a right triangle, that should equal 65, the square root of 65, squared. So for it to be a right triangle, those should be equal. Well, I know that when I square a square root, they undo each other, they're inverse operations, so I know that this would go to 5, this would go to 41, and this would go to 65. Well, 5 plus 41 is 46, which is actually smaller than what we need to have a right triangle. So in other words, the hypotenuse is too big. If we think about the hinge theorem, the hypotenuse or at this vertex here at B, that angle had to swing open bigger than 90 in order for us to have a longer than we need hypotenuse. So since it swung open bigger and the hypotenuse is too long, we do in fact know that we have an obtuse triangle. So this triangle ABC we would classify as scalene obtuse.